Hey everyone, and welcome to our first lecture video. In this lecture I want to just do a review over Python. For anyone who took 135, this will be a good refresher, and for anyone coming in from a different programming language like maybe the 140 course where you learn Java, hopefully this will draw some parallels from Java into Python and make you a little bit more familiar with the language. Okay, so the audience here, or the intended audience, is for anyone who has passed 135 or 140, someone who is familiar with algorithmic design, and already familiar with basic control structures. So when I say control structures, what I'm talking about are if statements, for loops, and while loops. So getting started, I want to introduce some of the basic data types that are used in Python. Okay, so and a lot of these, well, all of these correspond back to a data type used in other languages like Java. So we have integers, these are whole numbers, 3, -10, 1000. We have floats, these are numbers that have a fractional part or something after the decimal point. They can be positive, like 3.14, or negative, like -2.34. You'll notice if you're coming from the Java world that there is no double. So float is what we got. So if it's something with a fractional component, we're going to call it a float. str is a string. So a string is just a collection of characters denoted by either single or double quotes. So it doesn't matter if you use single or double quotes. What does matter is that whatever you started the string with, that you end it with it as well. And then also here we have bool, which is short for boolean. That only has one or two, or I'm sorry, it has two possible values, and that's true or false. And we typically use bools when we're evaluating conditions. Okay, there's some more data types. These would be collections or data types that hold other data types. So our first example here is a list. If you're coming from Java, you're familiar with arrays. A list is very similar to an array. Now, one thing that you'll notice is different and you'll probably like is the fact that a list does not have to contain just the same data types. So we can see some examples here. Here's one list. A list is denoted with square brackets, and each element is separated by a comma. So 1, 2, 3, 4. It's indexed just like as we would with an array. We start at index position 0, contains a 1. Index position 1 contains a 2, and so on. Here's another example right here of a list that contains strings, Alice and Bob. But what I wanted to point out is that a list does not have to contain just the same data type. We can have a list that contains a string, an integer, and a boolean, or any other combination of data types that we'd like. Alright, in addition to a list, we also have a tuple data type. Tuple is very similar to a list except for a few things. It's denoted with parentheses instead of square brackets. And the big difference is a list is immutable. And what that means is once we create a list, we cannot modify it. We can't take things out of it. We can't change the values that are there. Typically, we would use a tuple when it's something that is not going to change. That's in contrast to a mutable data type like a list where we can change things. So if I wanted to, I could change this element at index position 3 to a 5 if I wanted to. I couldn't do that here at index position 3 with the tuple. I'd have to create a brand new tuple to do that. And then the last collection data type we have is called a dict. That's short for dictionary. So a dictionary, if we think of it as the actual book, we can look things up and we can find their definition. Very similar notion here in Python in that we have keys that have values associated with them. So let's look at the syntax for this real quick. The syntax starts with a curly brace, a key, which can be any immutable data type, so one that doesn't change, strings, ints, something like that, is perfectly valid for a key. And then the value can be any data type. So this could be mutable. We could have a list as the value that's associated with this key. Same thing here with the fave color key. We can have, and it looks like I'm missing a quote right there, so forgive me for that. Syntax error. But green would be the value associated with the fave color. Variables, the way that we name variables is pretty simple in Python. We can start off with any character, so an uppercase letter or a lowercase letter or an underscore. Anything else would be invalid. So we can't start off with a number like 3. We can't start off with a $sign or an @ symbol or something like that. It has to be an uppercase or lowercase letter or an underscore. Now, after that first character for the variable name, it can be any of these characters or also a digit. So some examples here. This is a valid variable. It starts with an underscore. We can then, it's perfectly valid to have a number follow that and more underscores. So Three Stooges. We could also call it this, Three Stooges, but what would be invalid would be like Three Stooges, or this would probably be a better example if I put the $sign first to sort of illustrate that we can't create a variable name that starts with a $sign or any other special character. How about declaring and instantiating variables? Well, in Python it's very simple. One thing you'll notice if you're coming from Java is that this is not a strongly typed language, and what that means is it's loosely typed, and Python particularly uses a type of typing called duck typing, where whatever is assigned to a variable, if it looks like a duck and it quacks like a duck and it walks like a duck, then we're going to call it a duck and treat it like one. So looking at these examples right here, these accomplish the exact same thing. We have a string name equals Bob. Well, up here all we have to do is just say name equals Bob. Python's going to go ahead and infer that the data type for name is a string because the value that was assigned to it is denoted in double quotes. Same thing here with this int age equals 2. So we're creating an integer age and assigning it 20. Well, in Python, all we have to do is just say age equals 20. Python's going to look at this and say, oh, you know what? That's a numeric literal, is an integer, so that's the data type of age. And then lastly here on line 4, we can see an example of how we would do a formatted print. So in Java we would do system.out.format and we would use our format specifiers %s and %d. So just to recap, %s is for a string, %d is for an integer, and then we would list the variables that are going to substitute back in the correct order. So the first thing we come across here is a %s. The first variable specified after the string is name, so that will get subbed in for %s. Age will be subbed in for %d. We have that exact same notion in Python, and we can see that on line 4. Our print statement takes care of this. So there's multiple ways to write print statements. The way that we can do it formatted, like we did down here, is like this. We do our string literal that contains our format specifiers, so %s and %d, those are the exact same. And after our string literal, we do the %sign or the modulo sign, followed by a tuple containing the variables that we want to substitute back in for %s and %d. And obviously the order matters as well, so as we're looking from left to right, we're going to want to order them in that manner over here in the tuple. So very simple again, the first thing we came across was a %s, and name is the first thing in our tuple, so that will be substituted in here, and age will be substituted in for our integer. Awesome. And ultimately they both print out the same thing. One other thing that we can notice here is that the way comments are done are a little bit different in Python than they are in Java. So in Python we preface a comment with the hashtag. In Java we can use double slashes and that will comment out the rest of the line. There's also multi-line comments in Java, and we don't have a notion of that in Python. What we would have to do is just preface each line with a hashtag. Okay, so input and output. The way that we do inputs, or I'm sorry, let's talk about outputs first, is with the print statement. So print takes in its most simplest form a single argument, and that is the string that we would like to print out to what I'm calling standard out here. So standard out corresponds to our terminal, our command prompt, or our console, however you want to refer to it, but that's what gets printed out to the user. So I've got a couple of examples here. On line 1 I create a string called Bob. Notice that it's perfectly okay to denote strings with single quotes in Python. So that's assigned to the name variable. And then I have 5 different print statements that all print the exact same thing. And what I'm trying to show you here is that there are multiple ways to accomplish a print. Now there's little details associated with each one that we're going to want to keep in mind. So I guess the simplest example is on line 2, where we just say exactly what it is we want to print. Hi, my name is Bob. On line 3, that's going to print the exact same thing, except for we separated the string literal here and the variable with a comma. So what's going to happen is this hi, my name is will get printed to the console. The comma puts an implicit space after the close quote here. So there'll be a space like we see up here, and then it's going to print out the contents of the name variable. On line 4 we do the same thing, but instead of separating our literals and variables with a comma, we're going to do something called string concatenation. And we use the concatenation operator, which is the plus sign, to accomplish that. So, hi, my name is. Notice that if I use the concatenation operator, I have to put that space in if I want it printed. Okay, so there's a space after the S and before the close quote, and we're just going to essentially tack on to the end of this string the name variable. So it's going to look in memory and it's going to say, all right, what's associated with name? It'll pull out Bob and concatenate it with this string literal. Another example of a formatted print like we saw on the last slide is here on line 5. So print, hi, my name is %s. So that's a format specifier to substitute back in a string variable. And if we only have one format specifier, we don't have to necessarily put this in a tuple if we don't want to. We could just put the variable afterwards. Okay, so that's the only exception to that. If we had 2 format specifiers here, this would have to be inside a tuple denoted with parentheses. Another way to do a formatted print is to use these type of placeholders, curly brackets. There's a whole section in the book that talks about how you can do this, and there's different specifiers that we can put inside those curly brackets to limit the field width or the number of decimal places after the decimal point. In its most simplest form, it's just an open and close curly braces, and from left to right it's going to substitute back in. So we only have one here, name. We use the dot format method, and as an argument to format we tell it what we want to have substituted back in here. So if I had multiple substitutions I wanted to make, they would each be passed in as an argument to this format method. So we would essentially just put a comma followed by the next variable, and then another comma followed by the next variable until we had the right number of variables for the right number of format specifiers. Now, inputs is a way to write something to standard out and also get input from standard in. So standard in corresponds to the keyboard for the most part. That's where the user is going to be typing something in, and we can take that as data and store it into a variable. So we can see a couple of examples of that over here. On line 1, I am prompting the user for a name. So name colon. This is the prompt that will be printed to them. And then I'm going to store the result in the name variable. On the next line, I need to, I'm creating an age variable and I'm doing an input. So I'm inputting the age, I'm giving them the prompt. And then what gets returned needs to be converted to an integer so that I can use it later on. So let me actually just open up idle and let's take a look at these in the interactive prompt. So if you haven't already, I encourage you to go back and watch the video on getting familiar with idle and the IDE. So in this interactive prompt, let's do a name equals input in our prompt, and the interactive prompt is going to run this immediately. So when I press enter, it's going to go ahead and we can see it's printed out this part, which is the prompt, and it's waiting for me to type something in. So I could put my name in here, and now my name is stored in the name variable. So if I wanted to, I could do an example like above and say, hi, my name is %s, and then sub back in the name variable. And we can see that it looks up what's stored in the name variable and replaces it with the value that's stored there. Okay, in the next example here on line 2, we were getting an age. So age equals, let's say we just did it as input age. Okay, let's put this in. Let's say 30, and if we print the age, we can print it out just fine. Let's see, you are %s years old. Now there's a reason I'm making that be %s, and that's because anytime we do an input, by default that's going to come in as a string variable. Okay, that's very important to keep in mind, because watch what happens if I wanted to convert this age to a dog age. Well, the typical algorithm for doing that is to take the age and multiply it by 7. Okay, if I do that, Python accepts that line just fine, but now if I go back and let's just copy this and print it out. Oh, shoot. I did age again. Okay. Let's make this be dog age. There we go. So what happened here? Because 30 times 7 should be 210. And instead what we see here is 7 30s replicated one after the other. Right? So when we are multiplying a string by an integer, what it does is it just replicates that string however many times that we told it to. Okay? So even though we're not strongly typing everything, we're not declaring our variables as a certain data type, we do need to be cognizant of what the data type is of a variable that we're using. One way we can find that out is to use the type function, and we can see that the type of age is string. Okay, so let's do this example again, and this time let's convert it to an integer. So one way we can do that is we can say age equals int, and inside this, well, int is a function, and as a parameter it takes a string, and we know that input returns a string. Okay, so if we pass in this as an argument to the int function, this input is going to prompt the user like we did up here. When I enter 30, it's going to pass that as a string to the integer function, which is going to convert it from an str to an int. Okay, and we can see that here. We can run it, and then if we do the type of age, now we see it's an int. And then real quick, let's convert that to dog age times 7. And then if we print that out, we do the correct arithmetic this time and we come up with 210 years old. Now there's another way that you'll see inputs done in the book, and I feel like it's a longer process, but I just wanted to show it to you in case you see the book doing it, you understand what's going on. And basically we don't have to provide a prompt string inside the input. You can see here on line 5 I'm calling input and just open close parens. Well, that does the input and it waits for something from the user, but typically we want to give the user a little bit of notice and say, hey, I'm asking you for something. The format we typically do that in is something like name colon. Okay, so we can accomplish the same thing if we print age and then say that the age equals int input. That's going to wait, then I can enter something and we can see that age has 30 stored in it. Okay, and you may have noticed that since this was broken down into 2 lines, it didn't play very well here inside the interactive prompt. So the interactive prompt is great for testing code out. However, sometimes you'll run into issues like that, and the typical use here when we write a program is to not do it here in the interactive prompt, is to create a new file, and in there we could do something like print age colon age equals int input. Okay, so nothing inside the parens there, and then we can print out, let's say you entered %d this time, because that's going to be an integer now. And then we would save that. So I'm just going to save that here real quick. And then you can run it by going to run module. And what that's going to do is it's going to run that whole script over here in the interactive prompt, and you see I can enter something now. One other thing that I want to show you when dealing with this is when we're doing outputs and we're concatenating, we want to make sure that we are concatenating data types that agree. So what's on the left hand side is obviously a string here. What's on the right hand side also has to be a string. And I'll show you what I mean here. Let's go back here into the interactive prompt, and let's see, age has 30 stored in it, and the type of age is an integer. So if I wanted to print something out like you are age years old, I'm going to have a problem there, and we're going to get something called a type error. So there's something wrong with our data types, and what it's saying is it can't convert an int object to a string implicitly. And essentially what's happening is it's looking right here at this first concatenation, and it's saying, okay, the left hand side is a string, so I'm going to interpret this as the string concatenation operator, but I don't have a string on the right hand side, and I'm not going to change this to a string without you telling me to do so. So that's what it means by implicitly. So if we want to use string concatenation, we still can. We can say you are, and we have to explicitly convert that to a string. and that'll make Python happy. Okay, so it'll change that for us. What I highly recommend is to get familiar with using formatted prints. I know lots of times when people first learn about it, they prefer to rely on string concatenation or perhaps this other method of separating literals and variables with commas. But once you get into building up complex strings and they have a lot of different data types in it, I feel like it's a lot easier to just come in here and say you are %d years old and just sub back in your variable. To me, that just looks cleaner. Your string literal doesn't have to be broken apart into multiple pieces, and I just find it a little bit easier to read. But by all means, as long as you get the right output, I do not mind whichever method of printing that you choose to do. Speaking of type conversions, so we just took a look at that. I want to show you that you can convert to whatever type it is that you want to convert to. So the ones that we're going to pretty much be using are int, and this converts whatever x is in this case to an integer. String, which will convert whatever x is to a string, so maybe x is an integer or a float. In that case, we'll convert that to a string. And if we needed to convert something to a float, we could use the float function, and whatever we pass in would get converted to a float. Now, of course, if it can't, so let's look at an example of that. If we try to convert something like 3.14a, well, let's put it in quotes here, 3.14a to a float, we can get value errors here, and that's when the conversion is not possible. So all three of these are going to try their best to do the conversion. Just realize if they can't, you may get a value error. These tracebacks are very informational. They tell you what line something happened on. Lots of times you can go back and look and figure out why that value error occurred. Additionally, here I want to point out that the type function exists. It's really useful inside the interactive prompt so that you can find out the data type of a variable that you are using. And then also remember to keep in mind that the input function always returns a string. So if you're going to be doing some sort of arithmetic like we did with the dog age, make sure that you convert your inputted variable to either an integer or a float, depending on what you need. Alright, so moving right along here, let's talk a little bit about branching. Branching is how we make decisions in a programming language. Now, everything's pretty much the same if you're coming from Java. What's different is going to be the syntax. So let me walk through the syntax here. You should already be familiar with the fact that to do a branch we need an if statement, and optionally we can have some else if statements, and we can also have we can have 0 or 1 else statements. What we don't have, and it's probably pretty obvious from the screenshot, is we don't have to put our condition in parentheses, and we also don't denote blocks with or bodies with curly braces. So in Python, spacing is very important. So white space is not always ignored. Sometimes it means something, and in this case we can see for the if statement we're saying if the age is less than 17, so no need for the parentheses, just put your condition here. At the end of your if statement you need a colon, and that colon is the start of the body of our if statement. So on the next line it's going to look for an indented body. Now by convention in Python we indent with 4 spaces. It could be tabs if we want it to, and if you go that route of using tabs instead of spaces, just make sure that that's what you're doing throughout your entire program. If you start mixing tabs and spaces, you can make the interpreter mad. It won't realize what you're trying to do, and it's just going to throw up errors that can be kind of frustrating because you're really just dealing with white space. So um, here's an example of an elif. So an else if, the keyword here in Python is elif, followed by the condition, colon, and then the body, which is indented. Now, this is a very simple example. Obviously, bodies typically involve more than one line. Each one of those lines has to be indented to the same indentation level. So if we're doing 4 spaces and we need another line in this body, we need to go another 4 spaces on the next line so it lines up with this print. The way that we show that we are done with the body for an if or an elif or an else is we dedent back to the same level that we started on. Okay, so when we dedented back here and wrote elif, Python knows that everything that's indented between this if and elif is the body of the if statement. And of course, only one of these print statements is actually going to execute based on if the age is less than 17 or if it's greater than 64. And the only way that we would get to this else is if both of these were false, and we could assume that we are 17 or greater or 64 or lower. Looping follows the same idea here with the body. A while loop starts with the keyword while, followed by our condition. We're going to keep looping while that condition is true. And our body has to be indented. And again, by convention, that's 4 spaces. Okay, and we can have as many statements as we want inside the body. And when we're done, we dedent back to the same indentation level that the while was on. We typically use a while loop whenever we don't know how many iterations are going to occur. A good example of this would be if we're doing input validation. Let's say we're playing a game, and at the end of the game we ask the user, would you like to play again? Enter yes or no. Well, they could enter P, and that's not yes or no, so we need to prompt them again, and we have no idea how many times they're going to make that mistake, so we would probably use a while loop for that. Now, a for loop is a little bit different than the for loop that we use in Java. So there's a way to do a for loop like what we do in Java, and we'll talk about that, but the basic use case for a for loop is more equivalent to the what's known as a for each loop in Java. So for some element in a container, so a container would be one of those data types that we talked about earlier, one of these collections like a list, a tuple, a dict, or even a string, because a string is a collection of characters, right? We could loop over each one of those. And again, we would indent for our body and dedent back when we're done. What this is going to do is it's going to loop over each element in the container. So each of those elements will be assigned to this element here. This is a variable that we create. It's only visible here inside the for loop. And we typically use a for loop whenever we know how many iterations are going to occur. So if we know we want to do something 10 times, no sense in using a while loop because syntactically it's just simpler to use a for loop. Or the other use case is when we're looping through container elements because it's just so much simpler to do that. Now, that's not to say that any loop that we write in a for loop can be rewritten as a while loop. So let's look at some examples of that. So at the top here is an example of a number game where you want to guess a number between 1 and 10. And let's say that we're doing some input validation. We want to make sure that the user actually gives us a number between 1 and 10 because conceivably we're just doing an input here. They could totally enter 99 or 1000 or -1. and that would not fall in our range. So we're going to do some input validation here, and we're going to use a while loop to do it. So with our while loop, our condition is while the num is less than 1 or the num is greater than 10, print out invalid number, guess again, and then we just repeat our prompt. So we grab a new num, we convert that num to an integer, we'll come back up and evaluate the condition again using our new num, and if this is still true, we'll come back in again. Once this becomes false, then we'll carry on with whatever code proceeds on line 8 and below. Now, an example of using a for loop is like in the second screenshot where we have a collection. More specifically, we have a list of strings here, Alice, Bob, and Charles. And we're saying for each student in students. Now notice the student variable is not defined yet. We are essentially defining student right here inside the for statement. Students has to already been defined because that's the collection that we're going to loop over. And it's going to print out the student on each iteration. So the first iteration is going to grab Alice. Alice will be stored into student. It'll print that out. It'll come back up and it'll grab the next one, and Bob will be stored into student. It'll print that out, and then Charles, print it. When it comes back up, it'll see that it's done with all of the elements, and it will exit the loop and pick back up here on line 6 with the program. So one thing I want to do here is let me come back into idle, and let me just show you what that looks like. So we have Alice, Bob, and Charles, and we're saying for each student in students, print out student. Okay, and if I run that, notice on each line it prints out one of the elements out of that list. If I grow the list, that's all good because it's still going to print out each element. Okay, now I had mentioned we could do the same thing with while loops. So if we wanted to, we could say we could use a variable for the index position like I, and say while I is less than the len of students. So the len function is how we can get the length of a collection, colon. Notice that idle indents for me. That's very nice, one of the features of an IDE. And we just want to print out students sub I. So that's how we can pull things out of a list. We can address it using the index. Very similar to how we do that in Java. And then of course at the end we want to make sure that we increment I by 1. Now, if you're coming from Java, one of the things that you might miss is the prefix and postfix operator. So the I++, we do not have an I++ in Python. What would be the closest to that is this I plus equals 1, which is functionally the exact same thing as I equals I plus 1. Okay, so let's run that just so you can see that it produces the same output. So like I was saying, for loops are really just sort of syntactic sugar, so to speak, and we could really do everything with while loops if we wanted to. However, I know I do, and most other people find for loops a little bit easier to read. Now lastly, I had mentioned that there was a way that we could do for loops similar to how an actual traditional for loop is done in Java. And so in Java, we would probably have something like for int I equals 0, while I is less than like students dot length I++, and then we do like a system dot out dot print line students sub I. Let's do that, but turn that into Python. Okay, so Really, we're still doing the same thing with the for loop. We're going to say for I in, and we can generate a collection by using the range function. So range, we can see here, has a start, a stop, and a step. So start is where we're going to start at. And let's say we want to start at 0, and then stop is what we want to go up to, but not including. So we can take the len of students here. And then step would be if we didn't want to increment by 1 each time, we could skip every other one by putting a 2 here, or every third number by putting a 3 here, or we could go backwards by putting in a -1. But by default, it's just going to grow by 1 each time. And just to show you what that's doing, let's print out I real quick. So we can see now we get 0, 1, 2, 3. And if we're looking at our students list, we can see that that corresponds to the index positions. So we could print out students sub I. So we effectively just wrote the exact same loop 3 different ways. The preferred method is to do something like this on line 3 and 4, but I wanted to show you that if you wanted to do a counted for loop, you could do that as well, like on lines 6 and 7, and is functionally equivalent to what we see on lines 9 through 12. Functions. We haven't gotten to functions yet, and this is actually where we're going to pick up here in the course. So once we get through this week is completely dedicated to reviewing Python, getting up to speed, practicing with it a little bit. Next week, we'll get into creating our own functions. At the very end here, I have some resources. We're going to be looking at this practicepython.org this week, but there's some other great resources like pythontutor.com/visualize. I want to take just a quick second to point this out to you. I highly recommend you use this. A lot of students find it very valuable, and if you email me for help, it's probably going to be one of the first things I ask you is, did you try running it through the Visualize tool and see if you could figure out the mistake yourself? So what you can do is you can take some code and make sure you have the correct version of Python selected here. We're using Python 3, so the syntax is a little bit different for Python 2, so make sure you have the correct version selected there. I'm just going to take this code that we have right here and paste it in, and then you can click on Visualize Execution. And what this does is essentially a debugger in the browser, and it lets you step through the code one line at a time. So the next line to execute is red, the line that just executed is green. So if I next, this one just executed, we can see in memory we have students, and students points to a list with our index positions. Now we're right here in our for loop. Now we've created an I. We see it starts off at 0. We're going to print out students sub I, and we can see that in our output. Now we come back up. It's going to grab the next number in the range. We see that I changes to 1, and it prints, and we can just step through one instruction at a time through our program, and lots of times this is where you can figure out where the bug is, either in your logic or maybe your algorithm's wrong or something like that. Alright, so I highly encourage you to bookmark this, use this resource. There's some other great resources here, CodingBat, LearnPython.org. When it comes to the different functions that are available in Python, like the len function, this docs.python.org is a great resource. Our idle does a good job of showing us what I call IntelliSense. So let's see, if I say len, it's going to tell me what it's expecting or what it does. It returns the number of items in a container, so it's expecting for me to pass in a container here. But if you want some more detailed information, you can go to that docs page here, and let's say we're in Python 6.3, and we want to look at the library reference. So lots of good stuff in here. We can just do a search for Lin. Of course, a lot of things, or a few things, are going to match that. Let's try a quick search. And we can see here's our Python function, len, and it returns the length or the number of items of an object, takes one parameter. So we get a little bit more detailed information that way. Additionally, I have an old playlist here for 135. I'll also link in Moodle the current playlist for 135. If you click on this, it takes you to a YouTube playlist, and this is a little bit different than what I've been going through with the most recent iteration of 135. So there's these videos, and then there's a separate playlist that, again, I'll link in Moodle that you guys can use if you need to go back and brush up on some of these different topics that we talked about here today. Alright, so with that said, that's it for this lecture. Hope you enjoyed it. Hope you enjoy going through and learning about Python this week and reviewing some of the concepts that you already know. If you have any problems, questions, concerns, please feel free to reach out to me. And if not, I'll see you guys in the next video. Thank you.